Hello Javatarians, welcome back to today's AP Computer Science lesson is about Boolean algebra. It's really just using our and, or, and not symbols in more complex expressions. It's named after a British gentleman named George Boole. He created a formal way of turning and, or, and not into algebra. Now we've seen ifs and Booleans before, but a Boolean, anything that can be true or false, no other values. Not sometimes, not maybe, just true or false. And the ones we're going to talk about are the and the or, and they're near the bottom of the order of operations after the parentheses, etc. The other one we will see, however, is the not expression, which is that exclamation point, which is near the top. And or are evaluated nearly last in our order of operations. And these are the three types of expressions we'll see. We've seen and, 2 ampersands, or, 2 pipes, and the not expression, which is new, I don't think we've talked about it in class, is the exclamation point. With an and expression, everything must be true. So, in order for this if statement to be executed, total has to equal 17 and num has to equal 92. And don't forget about the double equal sign when you're checking for equality. If I change one of these values, this and statement is no longer true. They both have to be true. If you ever study electrical engineering, you'll see this type of symbol and this inverted V for and. And here we have what's called a truth table. And with I being C and S, if C is true and S is true, if C is true and S is true, then I, which is the and, is going to be true. However, if one's true and the other's false, the and, also known as the conjunction, is false. And if they're both false, then they're certainly both not true. And C and S, which is I here, is false. Or allows any of the conditions to be true. In this case, total equals 9. Num does not equal 31, but that's okay. Only one of these has to be true for the code down here to be executed. And also in engineering, electrical engineering, you'll see the V, like the union symbol in math, and this symbol for drawing diagrams if you study electrical engineering. Again, if C and S are both false, then the result I is false. However, if either one is true, C is false, S is true, C is true, S is false. In either case, the result, the or, is true. And if they're both true, then certainly the result is true as well. And summed up in a truth table, right? If you have one true and one false, the conjunction and is false. Right? The only time the and is true is when both sides are true. And similarly, the only time an or is false is when both sides are false. Not means the opposite of. So it takes, if something is false, it makes it true. For example, if we have this string that equals a fail, okay? As you'll remember, this expression checks to see if it's the same as pass. They are not the same as pass, so this is false. But putting the exclamation point in front of it makes it the opposite of, so it takes this false expression, right here and turns it into true. So the code here would, in fact, be executed. And so if your input, if you start with a false, the not makes it true. Likewise, if you start with a true, the not will turn it into false. And this bent arm symbol is the engineering symbol for not. You'll see it also in advanced math classes. We will be using the exclamation point. So let's look at a couple basic examples in our friend logical.java. What's going to happen here? We set the variable 1 to 60 and the variable 2 to 40. Okay, so let's see what's going to happen. If 1 is greater than 50 or 2 is greater than 50, well, in this case, one of those is true, so we will print that out. Okay. Here we have an and, the same statement with and. Well, half of it's true, 1 is greater than 50. However, 2 is not greater than 50, so the and, which requires both of them to be true, is not true. This will not be executed. Here we have the not. So the expression we just had, 1 greater than 50 and 2 greater than 50. We know that's false. However, when we put a not in front of it, it takes the false, turns it into a true. So this code will be executed. Last but not least, the other use for not is not equal. So we're here checking to see if the variable 1 is not equal to 50. Well, that's true. And 2 is greater than 50. Well, that's not actually true. So the entire statement is false. We won't see this code. So again, the or statement is true because one of them is true. Here, the and statement is false, but it's got a not in front of it, which makes it true. Those two will be executed. We get the first and the third. And as an earlier slide suggested, we can use not and logicals and equals and such with strings. Just remember that we use the dot equals when checking for equality. So if I run this, it asks me for the secret password. Well, let's try Gagongwa. Nope, that's not right. If we take a look, it's going to take what we type in as password, and it's going to compare it to the saved password. CS is fun. So if what I type in is the same as that, with the not in front here. So if what I type in is not the same as the saved password, that's when I get, sorry, try it again. If they are the same, then this statement is false, and that's when the else kicks in. So to demonstrate it, if I type in the same as the saved password, I get the other response. So that's the introduction, the fundamentals of Boolean algebra. In the next talk, we'll talk about some more complicated expressions when you'll see in the AP setting.